All right, I think we are good to go.
All right, perfect. So before we get started, how many of you guys have like used the Linux shell or like your terminal before? You can just like drop it in like the chat if you did or not. See, Evan raised his hand. All right, nice. It's okay if you haven't, because that's what, this workshop is about. All right, perfect. Yeah, so without further ado, let's begin. So what is this shell that we've been talking about this entire time? Normally we have like a graphical interface to do tasks such as like creating, renaming, or deleting files on your computer, or even running applications. And some GUIs or graphical user interfaces we see on Macs are like your Finder application, and on Windows, I believe it's the File Explorer. We can do things that are user-friendly, like dragging and dropping file slash apps in GUIs. And they generally have a really nice, they generally really have nice graphics, hence the name. The shell is actually a command line interface. And back then they only had these CLIs such as the shell and none of these like fancy GUIs. The shell is basically a program that takes in commands from your keyboard that you type, and it gives them to the operating system so that it can perform those commands. And in the old days, it was the only user interface available on a Unix-like system such as Linux. Nowadays, we have these GUIs in addition to the command line interfaces, such as the shell. And you might be wondering, okay, so why are we using these command line interfaces if we have the GUI already? And the answer to that is that you're able to execute multiple commands in like a single script rather than needing to manually click on certain applications or folders to navigate through like your files. And there are many different kinds of shells out there, but Linux tends to run a shell called bash, and that's what we will use today. So getting started, this might be a review for some of you who have taken like CS31 or 32, but for those who have not, we will just show you. And when you first log in to like the CSNet server, you're essentially granted access to the Linux operating system through the secure shell command known as like SSH, which stands for like secure shell. And this is why you like type in the command SSH and then your username at Linux server like 6.c.ucla.edu, because you want to access that OS through that shell. And so for today, you can follow along. If you have a Mac, you can use the Mac terminal since it's very similar to the Linux command line interface, or the PowerShell on Windows. If you go on like Windows or like your Mac like search option, you can just type those in and it should appear. And although we're using like the Mac and like the window like terminals and PowerShell, what like the Linux CSNet server has is an editor called EMACS, but we'll talk a little bit about that later on. So now let's see how we can navigate the Linux command line interface. So remember, we can't use our mouse to like click on different applications or drag and drop things. We just can type in commands and that's it. And the very basic commands you should first know are the ones to show certain files, enter specific folders, which are also known as directories. And you might hear us use those words interchangeably, folders and directories. And another command to show or put the current directory to a specific folder that we want. And so here is an image of the file structure. So the file structure for both your Mac, your Windows, or like the Linux operating system, they're all very similar in that it follows a tree-like structure. So at the top, you can see the root of your tree, and it's indicated by like that little /. And under the root directory, you have a home directory or home folder. Then you see under the home, you have two users, Jane and Pablo. and a temp folder, which just holds temporary files. You don't really need to worry about that right now. And then we see that inside Jane's folder, she has another folder called temp and a couple other files. Same thing with Pablo. Pablo has a couple of files in his folder. And also if we were in like Jane's folder, like that was our current directory and we wanted to go to Pablo's directory, we would need to traverse up the tree and then to the home directory and then back down to Pablo. And so now moving into what the actual commands we will use to accomplish this task of like moving into certain directories. The first one is PWD, which stands for print working directory. And what this does, it just prints the full path of the current directory or folder you are in. So if I type in like PWD in my terminal and it prints out /user/Jackie/desktop, that's the current, the working directory that I'm in right now. And the slashes for just indicate subdirectories. So if you see like under users, there's another directory called Jackie, and then under Jackie, there's another directory called desktop. For Windows, you might see it like print a little bit different. I think it has backward slashes instead, and there's like a C like drive prepended to it. But yeah, that's a basic like concept of PWD, just printing the current folder or directory that you're in. The next command is ls, which just stands for list, and it prints a list of all the files and directories in the current directory you're in. So if I was in like, the folder desktop and I type in ls in my terminal, it will print out file.txt, file2.txt, and then another folder called folder 1. That's just like an example. You might have something different in there or not even have like any files in there at all. And then we see we can change the current directory that we're in by using the cd command, which just stands for change directory. And after the cd command, we can specify what folder or directory we want to go to. So if I have cd folder 1, if I was currently in the desktop folder, what would pw print after executing the cd folder 1 command? You can just like type it in the chat. So Victor said files in folder 1. That's close, but that's something that ls would do. Yes, perfect. David, Dominic, and Nick. And so another side note is that the character or like the double periods, 2 sequential periods represent the previous directory. So if you want to go back up like the file tree or like a previous folder, you would type in cd and then space period, or ... And then a single period indicates the current directory. So if you type in cd space period, this will do nothing since you're already in that directory and it's pretty much redundant because that's already your current working directory.
All right, so while we're doing this, I think it's always a good idea just to have a little bit of a demo of the different commands that we're going over so you guys can see what this looks like in action. So feel free to sort of play along on your own devices if you'd like. Hopefully this screen is pretty visible for you guys and it's legible. Is the type on here too small? Because I think I can make it larger if you'd like. Or does it look good?
I think the size looks good, but it kind of got cut off, or like, I don't know if other people see it, but it looks,
yeah, it looks messed up on my screen.
Like messed up.
Interesting. Okay, let me.
We put solitaire and just.
Yeah, it looks like.
Let's say new window. Okay, does that look?
Yeah, that looks good.
All right, cool. All right, so yeah, we'll start out with the pwd command just to see where we are on my computer. This is my own personal computer right now that I'm on. So hopefully nothing too sensitive is shown. Okay, so here you can see that it prints out the directory that I start out in. This is just the sort of basic directory that loads whenever I open a new terminal session, which is users Travis Graining. And of course, if I want to see what I have going on inside that directory, I'm going to use ls. And as you can see, there's actually a whole bunch going on right here in LS. So I can open that up a little bit, but that shows like all the files I have in here and all the directories I have. And amongst those are my most usual ones. Like you can see up here, I've got desktop and documents and so on. And so that's where I want to be for the most part. So I can just change into, for instance, my desktop folder by typing that command cd, change directory, desktop. Now, if I print my working directory again, you can see that I am in users Travis Granning /desktop. So that's a little bit of navigation right there. And once again, I can click ls if I want to see what files I have in there. I'm actually not going to do that because there's a whole bunch in it right now. But the last thing we'll demo before moving on is just what Jackie mentioned last, which was the dot and single dot notation. So we'll just first demonstrate the single dot. Since we mentioned that a single dot refers to your current directory, if I type cd space and then single dot, then I click pwd again, you can see it's the exact same directory that I was in before I made that command. However, if I did cd with a double dot, then you can see if I print my working directory again, that I've moved backwards one directory. Now, one little cd command that we don't actually have in the slides, but that might be kind of useful for you in the future is cd hyphen or cd minus. And what this does is it'll put you back into the last directory that you were in. So for instance, right now, the previous directory that I was in before moving to this Travis Granning directory was in my desktop. So if I typed cd minus, then that would move me back up to the desktop. So hopefully that makes sense. So that's just like a moving to your previous window rather than moving directly through your file system. Anyway, let's move back to the PowerPoint.
All right, so now we have the basic commands of pwd, cd, and ls down. We can actually specify flags right after the command to provide extra functionality. And the syntax for to specify a flag takes the form a dash followed by a character, and there's like no space between them. An example we can see is the ls command. It can take in the flag A or the flag L, or even both A and L. And the flag A is just to list all the files and directories, including ones that start with the period. And the L flag is just to print in long format, which allows you to see stuff like how many bytes are in a file or when it was created, which is very similar to like the details you might see in like Finder or the File Explorer. And sometimes right after the flag, it will require an additional argument right after it, like a file name, and Travis can show you in his terminal just like a quick example of that.
Yes, all right, so we've seen what let me clear real quick. So does my terminal still look okay?
Mm-hmm.
All right, good. So we've seen before, I'm on the desktop right now. If I click ls, you can see all the files right here. There's a good amount of them, but still only one page worth. However, if I type ls, let me see, is it L? Then you can see a whole bunch more is printed right here. And that gives actually a lot more information about the different files. Like on the left, it gives permissions and a whole bunch of other stuff, like the dates and last times it was worked on and so on, and other information. And a lot of that you don't need to worry about now, but it is good to know that that -L is an option. Now, if we want to list, do the /A option or -A option now, we'll see some files that didn't show up before, like at the top over here. And some of these are files, some are directories, like you can see our dot and dot directory. And those are, of course, our current and previous directories that are now listed because we used that -A flag. Now, if we want to combine those two, we can just do ls-al, and this will do both. So for all those directories and files that weren't mentioned before, now those will be shown in all their gory detail. And so it prints out a whole lot more. All right, let's go back to the slides.
Okay, so now we're going to take a look at the man in the shell. It's actually not a who, but another command, which is like a help manual for the commands that you can enter in your terminal. And if you want to look at some information about a command, you would type in man followed by whatever command you want to look at, such as ls. And what will show up is a document or like buffer, which will give you the description, the use of that command, and flags of a particular command. And then once you're done with that, you can just type in Q to quit looking at the buffer.
Show that real quick up here again. So if we want to just talk about the ls command that we used before, we can type in man ls. And then you see a new screen pops up like this, and we can actually see some of the flags. We can see the flag -A that we used before. It says include directory entries whose names begin with a dot. And if we look further down, we should be able to see -L as well. And that lists in long format. And then there's a whole bunch of other flags that you can see that do different things when combined with ls. And so if you're ever looking for new functionalities for it, this is what you do. You just click man and then the name of your command and look through it. And then if you want to get out of it, all you have to do is press Q and then you're back where you started.
And now moving on to a different kind of man. We're moving on to file manipulation. So instead of just like visiting or listing different directories and files, we can actually make these directories and files as well as edit and print out their contents. So if you want to simply create an empty file, you can use the touch command. And an example would be like touch and then your file name that you want to create. And then after you execute touch file.txt, if you look into the contents of file.txt, you'll find that it's actually empty. And to obviously like fill it up with like information, you would use an editor, which we'll talk about later. If you want to make a directory, there's a command called mkdir, which is just make directory, or short for make directory. And then you specify your folder name. And then if you want to move stuff into a directory, it's kind of like when you drag and drop into a folder on your GUI, you would use the mv command, which is short for move. And then the two parameters that follow the move command, it's your source and then your destination. So file.txt will then be moved to the location in new folder. And then if you want to copy stuff into a directory, use the cp command, which is short for copy, and then your file, and then your folder, or your source, and then your destination.
All right, let's do a real quick demo of this if we can. So we're still on desktop right now. I'm actually going to create a new folder will just be like a folder for this particular workshop. So I'll call it sample. And now we can test that it actually worked by using our cd command on sample. So now we change directories into sample. If we want to see that that worked, we print our directory and we see, yes, it did. Now we have a sample directory in our desktop. But if we do our ls command, we see that nothing shows up. And that's because our directory, of course, is empty. So what command do we use to fix that? We use touch, just like Jackie said. That's the first command we learned about on this slide. So we can just say touch, sure, file text.txt will work. And so now when we ls, we have our file.txt represented here. So actually, I'm going to do one more thing just to show off our copy command. So if I change directories back out, I had earlier today created a file called sample.txt, which was in my desktop. So if I want to move a copy of sample.txt into this sample directory that I created, here's how I do that. I would just cp followed by the name of the file that I wish to transfer over, followed by the name of the directory I want to transfer it into. And now we can check that that worked by changing directories back into sample, ls, and then you can see that sample has shown up inside of our directory.
So now moving on to deletion. So if you made a mistake or want to get rid of a file, you have a very simple but powerful command called rm, which is short for remove. And an example would be rm space your file.txt. And all you have to do is just specify the file you want to delete, but it has to be within your current directory. And you would never want to use the command like rm and then asterisk, because that would just delete all the files in your current directory. If you want to delete a directory, and all its content, you would actually need to use the -r flag to delete recursively. And if you have an empty directory that you just like created somehow, but by mistake, you can use rm dir to just delete your empty directory. And another thing, if you guys see like trolls like on Reddit or something, and they say like, oh, to solve your problems, use like rm space /, and if you remember, like / means root of your file tree hierarchy. That's gonna delete all the contents on your computer. So don't ever fall into that trap.
Yes, that is a very mean solution that is often used to trick younger programmers. So let's see how we delete the stuff that we were just dealing with before. So first, we're just in our sample directory right now. And say I want to get rid of sample.txt. You know the command for that now. It's simply rm sample.txt. Click enter, and list again, and you can see that sample.txt has disappeared from our directory. Now, on the other hand, say that we actually don't want sample at the whole directory after all. So we might be tempted to go back a directory to desktop and then say, okay, let's remove sample. But you'll notice that that doesn't work if we just say rm, because sample is a directory. And so that isn't going to work. So what we want to do is use that -r flag we talked about before, and then that should work. And just to test it, we can try to change directories back into sample. And when we do, we see that there is no such file or directory left. I see there was a chat. All right, cool. Let's go next slide.
Okay, so moving on to more things that you can do. You can also redirect the output of a command. So sometimes a command will print stuff out onto your terminal, but you can actually redirect that into like another file. And the first command that we see is the cat command, which just outputs a file content to your terminal. And you can just specify the command cat and then the file you want to output. And what you can actually do is control where this output goes using the greater than sign or symbol. So if you do cat file.txt and then the greater than symbol, file2.txt, what that basically does is output the data from file.txt to file2.txt. And so using two of these, so two greater than symbols will append to the file, but a single greater than symbol will overwrite that. And then I just have like a question for you guys. What is a similar command to cat file.txt and then greater than file2.txt? We kind of just learned it, and it's like copying the contents from one file to another. You can write it in like the chat. All right, perfect. Eric, it is like the CP command, which just copies files. And then now moving on to the echo command, all it does is outputs the user input. So if you type in echo malarkey, your output is going to be just like malarkey in your terminal. And this is like very similar to like a print statement in like C++ or Python. And we can actually even redirect this to a file and write to it using the echo command and the redirection symbol, which is a greater than symbol. So if you execute echo some stuff greater than symbol file.txt, you will see the quote or the actual string some stuff in file.txt. But this can be a pain if you want to edit a text. You don't want to type in the echo command over and over again. So the solution is to use an editor.
All right, so we're going to get to editors very soon, but real quick, let's just go over what we learned on this slide. So we can start out with the echo command, which at first seems kind of useless. So we'll just did what I did before. So you can see if I type in echo malarkey, then it'll just print on the next line malarkey. So let's just echo it right back to you. And so that's the simplest way we can use it. But as we mentioned, we can actually write to files. So let's try that out. So say, for instance, I have a file. Let's create a file called sample2.txt. So I've created it. And now if I want to find what contents are in sample2.txt, we can use the first command we learned on this page, which is cat. So if I say cat sample2.txt, hey, what happened? Well, we created sample2 right now. So of course it doesn't have any contents in it yet. So we want to write to that. So let's say we want to put the word malarkey into it, because why not? So we can just use that redirecting right here to .txt. And now when we try cat sample2.txt, we can see that it has malarkey in it. So let's try one more thing, which is the catting some text from a file into another file. So I created a file earlier today that was called sample. So let's see what's in sample.txt already. So there's just a bunch of sort of random lines in there and ends with the word golly. So let's say that I want to append to the end of the sample.txt file. So I can use the cat command to do that. Let's actually append what's in sample2 to the end of what's in sample1. And if we do this, then we cat sample.txt again, we can see that the line malarkey has now been added to the end of it. So this is just a brief demo. There's a lot of capabilities that you can do with just these two commands. But let's move on to editors.
Yeah, so like I mentioned before, editors is kind of a solution to, or an alternative to using the echo command. And one of the editors that you might have is called Nano, which is really simple, but does not have a lot of functionality. And simply to edit a file, you just need to type in Nano and then the file name. Another text editor is called Vim, but sometimes it's very annoying to use since you have to press in a bunch of commands to do just something simple sometimes. However, for some people, it can be really powerful if you actually know how to use it. But there's also a debate whether Vim is good or EMACS is good. And also another big text editor is EMACS, which one of the CS professors, Egger, contributed to greatly. I don't know if you guys know Professor Egger, but it's not really fun to get egged by him. If you ever taken a class with him, he teaches 35L and CS33, I think. Yeah, so it's used in CS35L and it's pretty useful in general. Although the name is EMACS, it's not just used for Mac OSs. If you want to create a file using EMACS, just type in the EMACS command followed by the file name, very similar to what we did with the nano command. And then if you want to use any of the commands within EMACS, you either have to start using the control key or the escape key, which is also known as the meta key. And then after you press the control key, you will see on your terminal the letter C followed by a dash. And so if you want to execute the command search forward, you have to press control, which is represented by C dash, and then S. And then Travis will show you after how to use that if these words don't make sense. And then there's meta commands, which are just represented by a capital M followed by a dash. And so if you do the meta character, which is escape, if you press that followed by the greater than symbol, that will take you to the end of the buffer. And there are some simple ones, which is kill line, which is deletes an entire line, copying and pasting. So Usually, like in a regular like text editor, like Google Docs, sometimes you just do like Command C and then Command V. But in the EMACS text editor, you need to execute the commands, which are like on the slide, which is the meta character followed by W, and then the control character followed by Y. And then there's like a lot of commands in EMACS that that you might like see, but we're going to just go over that a little bit later.
All right, real quick, I'll go over a bit of this. So if you are just on your desktop and on terminal and you've tried using EMACS, you might be kind of confused because EMACS doesn't come naturally downloaded on your computer. So this would be a time if you haven't before and you want to use EMACS that you might want to log on to your CSNet account if you have one. Because EMACS is actually on your Linux servers up there. But I took the trouble of downloading it to my own computer, which is why it works on my desktop like it does. So let's do a real quick demo of some of the features of EMACS. So I mentioned I had my sample .text document before. So to open that, all I have to do is type in EMACS followed by the name of the file I wish to open. And then, as you can see, a file pops up, or a new buffer window pops up with the contents of the document in it. And so you can see all of the different lines right here. Some of your easy functions are the same, like you can still move around with your arrow keys, as you would expect. Now, one of the commands that's easiest to do when moving around is that meta right-hand arrow key that we talked about before. So you can see if I type the escape button in, you can see that escape pops up on the little window on the very bottom of it. Hopefully that's visible. And so my next command that I wish to put in, or my next character, I want that to be the greater than sign. And so you can see that my cursor jumped on the top. It jumped from the beginning of the document all the way to the end. Hopefully you can see that. So the same kind of thing should happen if I do the backwards arrow. And I can move to the beginning or the end of the file super easy like that, if that makes sense. So another easy thing to do is moving around to the end of a line. And to do that, all you have to do is hold down the control key and then click E, which goes to the end of the line automatically. So hopefully you can see my cursor doing that. If you wish to go to the beginning of the line, you can do Control A, which moves you to the beginning. And so these are just some easy ways to move around in EMACS. So just a couple more things that we're going to talk about before we move on a little bit. Is the search forward command. So if we do Control S, you can see that a window pops up in the bottom that says I search. So if I start typing in A for another, you can see that it'll start highlighting where A shows up or another shows up on the screen. Let's see, and just another couple ones. We want that kill line, which is just basically a cut. So to do that, you can do Control K on the line, and the line disappears. So if you want it back, all you have to do is paste with Control Y, and it goes right back. Now, query replace is kind of like a search functionality, but then you also choose text to replace it with. So you can experiment that on your own if you'd like. And there's just a ton of other really cool, interesting things that you can do on EMACS. I would highly recommend taking a look at the reference card that we included at the bottom right there. But for now, the last EMACS command that we'll talk about is exiting, which is just Control X, Control C. It asks if I want to save the file. I can just type Y, and then I'm back to where I started. All right, so that was the first part of what we're talking about today. The next part is getting a little bit more in depth with using Linux. And one of the ways we can do that is by learning about regex, which stands for regular expressions, but we'll get to that in a minute. So when we're talking about doing interesting and useful things with Linux, one of the things that we often want to do is search for files or for content of files or even for folders. And some of those commands that do that are ones like find and grep. And then there's a myriad of other useful commands, some of which are sed, tr, and wc, but we'll get into what those do in just a second. So you may have been wondering what I meant by regular expressions. And this is just basically a way of matching strings or matching specific formats of text. And so how you start to form a regular expression is by using some of these different sets of characters. So one of the special characters is known as an anchor, and that's either the little up arrow or this $ right here. And either of those, the first one, the upper arrow marks the beginning of your line, whereas the $ marks the end of the line. And please don't worry if this sounds all too confusing right now, it'll come together a little bit on the next slide. So we can also represent sets of characters in regex, and we do that by using brackets and then putting specific characters inside. So for instance, if I have this A, uppercase F, and G right here, this grouping matches a single character in the set. So it matches either an A, uppercase F, or lowercase g. So we can go beyond that and do some more sets, one of which is the alphabet set, as we can see right here. That represents any letter or any character in the alphabet, uppercase or lowercase. And then we can do the same thing with digits, although right here we use the not character, meaning that this set right here represents any character that is not a digit. All right, so we've also got quantifiers. So I mentioned that any of the sets that we talked about before just represented a single character that's within that set. However, we can also ask for more than one or specific amounts of characters. So for instance, if we have this asterisk right here, then that counts for 0 or more of the preceding character. So for instance, if I had my AFG set from above and then just had an asterisk after that, that could mean any number of these particular A, F, or G characters in a row. We can also have the question mark, which is 0 or 1 character of the preceding set, or the plus, which is 1 or more characters of the preceding set, or even a number specifically in brackets, which matches exactly n occurrences of that particular set. So one thing to note is that quotation marks might cause issues if the regular expression thinks that you are making a separate string, and some special characters like the asterisk or plus might cause issues, because if you're looking for an asterisk or plus, but have it next to a set, for instance, then it might think that you want it to be a quantifier on that set rather than its own particular character. And for these situations, use a backslash to do what's called escaping the special character. All right, so we've got through that slide. It's probably the most complicated one in this entire lecture, but don't worry about it. We'll get a little more in depth with it now. So let's go over a few examples. So I mentioned in the last slide that that up arrow is called an anchor, and what it does is it represents the beginning of your string. So for instance, if I had this up arrow right here next to the set 0 through 9, that would mean a word starting with a digit. Now, if I wanted a word ending with a digit, all I'd have to do is put a $ at the end of this right here. So let's think about how to put this together a little bit. If we want to represent an email address, for instance, we know that in the middle of our word, we're going to want to have an @ And so what we can do right here is create our set. We want the first bit of our email address to be any number of alphabetical characters or numbers. And so we can have that first, then we want an @ in the middle. We know we want exactly one @. And so we can use the brackets right here to specify exactly one @. And then we have another set of alphabetical characters or numbers. And this should also have an asterisk next to it. So next, for instance, if we want to match the string BO * BA, that's one of those special characters that we're running into right here that could cause issues, because that could think we're meaning exactly one or more occurrences of that O beforehand. So what we have to do is what's called escape it. And to do that, we do a backslash before the special character, and then it knows that that is nothing more than the asterisk character we're talking about. And one last thing that we can talk about here is that we can also use the OR operator, which we didn't mention before. So for instance, if we want to match a yes or no response, we can just put the OR between these two strings, and then it will match either of them. All right, so we've got an Amazon gift card question right here. I want you to describe this regex pattern right here. And detail is important here. There's several different points that I want you to hit. So it's most important that you get everything correct rather than being fast. But if you are the first person to get everything in it correct in the chat, then you'll get an Amazon gift card. So we're going to start doing that. Type your answer when you have it. This may seem kind of complicated, but you can just go through step by step and see what it means. And if anybody has any questions after a little while, then I'll be happy to address them. Out of curiosity, by the way, when I have the chat open on my end, like right now, can people see the chat on your end?
No, you're good.
All right, cool. All right, how is this question coming along? Is anybody getting close?
You can look back at the slides,
Sure.
or there's like a link that you guys can also look back on.
Yes, I think the link should be available for everybody. I think I resent it after everybody showed up. So if you need to look back at that, feel free to. So this is a little bit complicated, but the things we want you to talk about in your answer are just like which characters are acceptable, how many, and what their positioning is. So that's just 3 main things. Give it your best shot if you aren't confident. I like to see the thinking faces. That's good.
I think we got something in the chat.
Yes. That is part of it. Yes, there's just a little bit more. Everything right there is correct, but there's just a little bit more to add on top of that. So I'll ask a question. How many of those characters can we have? Just to get you thinking. All right, I think I'm going to give everybody about 30 more seconds to get an answer in. Whoever's answer is closest, we'll get our gift card. Yes, this is true, but okay, I'll go over it a little bit. I think I'll give 10 more seconds if anybody else has anything to add, and then I think I'll give it to Preston because he answered first, although he didn't get everything that was in there. All right, so you're correct about about it being a set where the first character is either an alphabetical character or a period or a dash or a underscore, because that's all that a set notation means. It's just whatever characters are acceptable. However, you'll notice that I put the asterisk to the right of it, and that means 0 or more occurrences of this letter. So it could be any number of these characters from this set. But what we do know is that it has to begin with this character. And I've also put the $sign at the end, which means that it has to end with that particular character as well. So basically, it just means any number of these characters in a row, if that makes sense. But there can't be any other characters in this set. So if anybody has any questions about that, feel free to type them in the chat. Preston, congratulations. We got you on that one. All right, sorry, that one was a bit of a toughie. Regex is a very complicated thing, especially when you first encounter it, and we're not expecting you to be experts by any means, but this will prepare you for when you have to deal with it again later on. You've now been inoculated against it a little bit. It's your first sighting, and it will seem a lot easier when you come across it again. All right, and yes, when and if you take 35L, you will have to become an expert in it. So let's move on a little bit. Okay, so why did we learn that? Why did we go through the pain and suffering? And that's because now we can get into some more useful Linux commands that will actually use regex. And so some of these are our sed command, which means stream editor, and our translate command. So first, let's talk about sed. It has a pretty weird format, and we're not going to go into all the options right here, but it's got this 3/ format, and it'll have 4 characters / options in it. And the first one is usually an S, and the last one I have is a G right here. All the G means is replace all occurrences. And so what the stream editor command does is it replaces all occurrences of original in the file name that we're talking about with the replacement word. And so this is a very weird format, and I don't think we see it a lot in Linux commands, but that's all it does. Say, for instance, our file had 5 occurrences of the word original in it, then this stream editor command would just go through and replace all of those with the word replacement. But an interesting thing to note is it doesn't actually do that in your file, but it prints out the contents of your file and replaces it then. And TR actually does a similar thing, although with fewer options. So for instance, our first TR command right here would take all instances of AB in your whatever file you feed to it and replace them with CD. And then the next TR command, or translate command, has a -D flag, and this just stands for delete, as you might imagine. So what it does is it removes all instances of numbers from whatever you feed to it. And so this might sound a little bit confusing now, so it's easier to just go through and demonstrate what I mean. All right, so let's do TR, because that one I think you might use a little bit more often. So we want to use our TR command we'll do AB to CD. And now nothing is specified for it, no input or anything. So what it's going to do is it's going to read from what we call standard in. So I can start entering stuff in. Let's say I have tab is the word that I enter in. And then you can see that it replaced the A and B with C and D right here. So it's working exactly as it's supposed to. And I can keep on actually entering in these words if I want to. You'll notice that it replaced the first occurrence of B with a D as well, because that's just how TR works. So now I'm going to close that standard input, and let's try it with deleting. So I want to delete, let's see, this should work, 0 through 9. Say I have, this is my input, then it'll filter out, it'll delete all of the numbers that I put in my string and feed to it. So hopefully TR makes sense. If it doesn't, as always, feel free to ask more questions and I'll be happy to answer those. But anyway, that's how TR works. It's your translate command. Let's get back to learning a little bit more. All right, so something we might also want to do, and we do a lot in our script, is we want to look for files that are further down in our file tree. And one of the easy ways to do that is, of course, as you'd expect, with the command find, which is what you want to use when you're finding. So there's a couple different commands that we can use with this. I'll just go over 2 of them now. If you want to find out more, you can always Google it or use the man page of find. One of those is the name flag. And so what this means is that you'll accept the name of a file that you want to search for, and this will output the path of that file. And of course, you'll probably encounter some sort of error if that sample file does not exist. And you may be wondering why I put the little dot right there, and that's because we want to search from our current directory downward. Remember, the single dot stands for current directory. So theoretically, you could also plug in the name of another directory if you wanted to search that directory for a particular file, but in our instance, I'm just including the dot. Now, the next command with find is just the empty flag, and that'll simply output all empty files and folders that are in your directory. And the period at the end of the empty is not intentional, so ignore that. So one other command that we might want to talk about is grep. So actually, that's a very good question. So does anybody have an answer to Evan's question? What would we put in place of the dot if we want to search through all directories? Perfect. Good job, guys. Yes, because our root directory is that / right there. So if we want to search through every single file, everything is downstream from the root directory. So we can just put that in instead. All right, so we might also want to look inside of files as well as trying to find files. And the grep command can help us do that. So for instance, if we use grep flag n a nincompoop on sample.txt, it'll output all lines in sample.txt that contain the word nincompoop. Now, if we want to get a little bit further out, and rather than searching inside files, if we want to search for files that contain nincompoop, we can use the -l flag. And the asterisk at the end right here just means search all files. So let's take a look at what we have right here and see if we can do some examples of it. So if I want to, for instance, find in the current directory by name, sample.txt, like we have right there, you can see it waits for a second because it takes a moment to search through all the files, but we can see that we have sample.txt and it's in our current directory. We can see that by the dot. So that works as we would expect. Let's see if I did find dot empty. Do I have anything? Oh, looks like I have quite a bit that is empty in my directory. I actually didn't know that. But anyway, you can see that these two find commands work pretty simply. Let me cat my sample.txt again, so just so I know what's in it. Okay, so let's say I want to search inside of sample.txt now for all lines that have the word R in it. So how I do that, as we see, is just do our -n flag. I'll search for word R, and then I'll type in sample.txt. All right, and we can see that it outputs the lines that we want. The -n flag actually outputs the line number beforehand, so we know that it's on the 4th and 6th lines, which can be pretty convenient. So theoretically, if I were to do the same command without that -n, we can expect that it would just output the lines without the line numbers. So this can be pretty convenient as well. And this is why we learned regex. Right now I'm using pretty simple things, just simple string matching, but we can use regex patterns in the place of those simple strings when we want to find more elastic patterns in our files. And that'll get a bit more complicated. So we'll just keep it simple for now and move on. All right, so let's talk a little bit about something we call piping and then a couple extra little commands. So first, some of those extra commands. One of the ones we use a lot actually is called WC, and all this is it stands for word count. And so it'll return 3 columns. The first of the columns will be the number of lines, the second will be the number of words, and third will be the number of characters in the file that you feed to it. So we'll see how that looks in a moment, but it's a pretty simple command. Now what the sort command does is it'll output the sorted version of the file line by line. And I believe it sorts alphabetically, but you can also reverse that order if you put the -r flag on it. Now it's important to remember that if you say sort on a sample.txt, it does not actually change the sample.txt file. Rather, it just changes the order of the lines in sample.txt when it's outputted to the screen. All right, so clear, I think you've seen me use that a couple times before. It's when your buffer just gets a bit hairy and ugly, you can just get rid of everything that was in it before by typing clear. And now a last one that we want to talk about is chmod. And this just changes permissions on the file. Like we remember seeing earlier on when I did the ls-l that it showed permissions on the left. And those are basically permissions on who's allowed to read, write, and execute to the file. So this can seem a little bit complicated, and you'll learn more about it later. But just know that chmod changes permissions. And one command that we'll be actually using later today is chmod +x. And this just means that you are now allowed to execute the file. For instance, if you wrote yourself a little program you would do chmod plus X to be able to execute it yourself. But let's talk a little bit about word count real quick. All right, I'm going to clear out. So if I want to find how many words are in my sample.txt, I'll just say wc sample.text, and we can see we've got 3 columns, as I mentioned before. We've got 10 lines in our sample.txt. We've got 15 words, and we've got 87 characters in our sample.txt. Now, there are certain flags that we can give to WC. I believe that the L flag.txt only prints out the first line right here. So if you just want to know how many words are in it, all you have to do is do WC -L. So now let's see what sort looks like. I'm going to cat sample.txt real quick. Okay, so we can see what's in it right now. It's not in any particular order. Now, if I type in sort sample.txt, you can see that all the lines are sorted when it's outputted. But now, as I said before, the actual file sample.txt is left unchanged. So if we were to cat it again, you can see it looks exactly the same unworded as it did before. So all that sort does is it outputs a sorted version of your file. And so I think you can imagine if we wanted to, if we created our own like sample2 file, I can do that now actually. I say touch sample2.txt. If I wanted to have a sorted version recorded somewhere, what I could do is say sort sample.txt and then put it into sample2.txt. And so now I've saved a sorted version for later, and I can just print that out whenever I want to. So just cool things you can do with the Linux command line. All right, awesome. Let's move on. So there's something called piping output that we can talk about as well. And this is how we sort of chain commands together. So I don't know if anybody's considered this before, but it would be nice if we could take the output directly from one command, say our sort command, and then pipe it directly into another command, say word count command. So let's see how that looks. We just have to use what we might be familiar with as the OR operator from before. And we can do that. I'll give a couple examples right here. So for instance, if I want to grep on a file, rather than actually providing sample.txt as an argument to it, what I can simply do is output sample.txt by using the cat command and then piping it directly into grep. And a similar thing happens if I want to, for instance, count all the number of files that I have in a certain directory. I can do that with the command shown below. I can do ls and then put the output from that directly into a word count command. So let's take a quick look at what that looks like. All right, so if I'm going to change desktop again, so I'm going to say, gee, I wonder how many files and directories and everything I have on my desktop. If I just do ls directly, it seems like that'd be a real pain to count. So what I can do is pipe the output from my ls command directly into a word count command, and then just only look at the first file. And you can see that I have 44 files and directories in my particular desktop directory. So that's just an easy way we can chain together different commands if we want to. Hopefully that'll make sense. Let me see, I think there might have been a question. Using find or terminally faster than regular search window, search Windows Explorer. I actually don't know if they are the same behind the scenes. I'm also particularly no Windows expert, but there are a lot of people who pretty much exclusively deal within command line interfaces like this. So what you're talking about, like the search functions, are going to be GUIs, like we talked about before. So sometimes that's just not an option. I mean, I think we can all agree that it's oftentimes easier if I just go up to the search bar and search for something than it would be to go in here and look through my whole file system for it. But sometimes that's not an option, especially if you're dealing with lower level systems. All right. So let's talk about our last subject of the day, which is going to be scripting. And this is sometimes if we've configured a really tricky set of Linux commands to do a specific function, then what if we close our terminal session, then it might be lost forever. So what we want to be able to do is save that set of tricky Linux commands so we can use them over and over again, and even without typing them out every time. So how we can do that is by doing something called scripting. So what exactly is in a script? Well, a script is a series of shell commands that you put together to perform a desired function. And it's quite useful because it allows you to, if you have it set up correctly, you can call many Linux commands at one time as a unit by just calling your script. And another cool thing about scripts is that they can use variables and loops, which are things that I think you'd have a little bit of a difficult time using just in real time in your shell. And so because of this, they're a very powerful and widely used tool, used a lot in industry, and they're just a very important topic in general. Also for your upper division classes, you'll want to learn this. So let's see a little more about scripts. So one thing that a script has to start with is called a shebang. And this is simply this weird line right here, the pound exclamation points, then /bin/bash. And this just basically is an absolute path that you're giving to your script to the bash interpreter on your computer so that it just knows how to run your commands. And then once we have this at the beginning of our file, we can simply just start putting in commands for our script to run. So let's try a really simple shell script. And I think everybody knows by now that your first program in a language is usually a hello world script, very hello world program. So we can do that same thing with a script. So I'm just going to create a file. Let's call it hi.sh. The .sh extension isn't entirely necessary, but it does just show that you're dealing with a shell script. So if you're going to create one, I would recommend using that extension. So then I'm going to turn to my beloved EMACS to edit this file. So it's empty right now, but the first thing that we always want to include is that shebang we talked about before. So I'm going to include the shebang right here. All right, then can anybody think of a command that will output something to the screen? I think we learned two of them that would probably work. One's easier than the other. Yes, perfect. Okay, let's see. But make sure if you're doing a multi-word output that you have quotation marks around it. Otherwise, I might think you're trying to give two arguments to it. All right, so we've got echo hello world. I think we usually want an exclamation point with that. So with EMACS, as I mentioned before, Control-X, Control-C allows you to exit. And let's see if this works. So we execute a script by doing a // But hey, we see that our permission has been denied. And this is weird. We're not used to that kind of thing. Does anybody remember the command that I mentioned briefly earlier that we use to change permissions? Perfect. Yes, we use chmod or chmod. So we want to add an execute permission for ourselves, and X is for execute. So we can just say chmod +X on hi.sh. Now let's try running our command again. There we go. We've run our script and it's doing exactly what we wanted it to. So that's our first very basic script. Oh, Preston didn't get any permission denied. Very interesting. I wonder if you have permissions set differently on your computer or if it just likes you. Could be either way, but hopefully everybody's following along to this. This is just a really useful first script that you can use. And then once you have this framework set up, you can modify it as much as you want to perform different commands. All right, so let's talk a little bit about something else, which is variables that you can use inside your shell scripts. So variables are declared with an equal sign, as you would expect, but there must be no space between the name of the variable and the value you give it. For instance, if I want to create a variable valid that's equal to true, which is a Boolean, I would just say valid equals true with no spaces in between. And I can do the same thing with numbers like 1 right here, count equals 1. And I can even do the same thing with like results of commands and so on and so forth. So that's variables. And you can also use expressions like we see right here. This might look a little bit odd, but we have our double parentheses used to evaluate an expression. And then we're simply setting our new area of the variable equal to 5 times 5. And then, so when we want to call our variables that we've created, we're going to prefix a $sign to the variable name when we call it so that it knows we're dealing with a variable and not trying to create a new one or something else. For instance, if I left out the $sign here, then all it would do is echo out the string area. So hopefully this makes a bit of sense. Let's move on to logic. So in addition to variables, loops and logic are also a thing in shell scripting. And this is very useful for our scripts, of course. So for instance, we have a while loop up above right here. We put our condition within brackets. So that's why we created, for instance, our valid variable up above as true. Then we call it in the condition for our while loop. So what we'll simply do is echo or print to the screen our count variable. Then in the middle of our while loop, we check our if statement, which is also denoted by brackets. And this dash EQ means equal to. And so if count is equal to 5, it'll break out. So a couple things to note are for our while loops, we need a do after our condition, and then we finish up our while loop with done. So that's the while loop syntax. And now for if statements, what we need is an if, but we also need a then following our condition. And finally, we need an fi when our if statement is over. So it's just like the reverse of if. So this might seem like a lot, and maybe it is, but this is just a good introduction for you to learn a little bit more about how shell scripts work. So actually one more thing. So if statements, there of course is if, else if logic, but in shell scripting, instead of else if, we have a simple elif is the term for that. All right, so for loops are also a thing. They're very similar to the C++ form. And they need the do and done commands just like while loops do. And you can see an example of that below right here. All right, so we're almost done with all this information, but there's a couple more things to talk about for shell scripts. So we can also, for our shell scripts, have arguments. Like we saw before, oftentimes our commands will need an argument like a file input or something like that to operate upon. And we can actually do that ourselves with our shell scripts. And fortunately, we have variables provided for us in our shell scripts to do this. And that means our $1 and $2 and so on are variables that we can call in our shell script to access those arguments. For instance, if we provide a single argument that's, for instance, a file name, we could call in the middle of our script, we can call that $1 and that will be equal to the argument that we passed in. So this is very useful, and you can just keep on having more and more arguments. And of course, the total number of arguments is equal to the total number of these variables that are created for you. And one more thing, you can also use the read command to get real-time input to your function. All right, so we'll go over, we're gonna have a very quick project on this, which we're going to do after our Kahoot. But first, I'll just talk a little bit about a couple of requirements that we want on it, and we'll go over it again after the Kahoot happens. So for our shell script that we're going to create in a sec, we're gonna want one argument that's a file name. We want to check if the file exists in our current directory, and if it does, we want to append a certain amount of text to it. So the text should also be inputted by the user, but after the script runs, so it won't be an argument. It'll be like in the middle of your script. You want to ask for text. Now, if the file doesn't exist that you're looking for, then no user input should be taken and your script should just end. So that's going to be our shell script. We'll talk about that in a minute, but for now, we're going to move on to our Kahoot. So if we could get that running real quick.
I have the Kahoot ready. I'm going to just share my screen really quick. Okay. On my screen.
Yes, looks good.
Okay. I'm gonna just turn the sound on.
All right, guys, and this is also for an Amazon gift card, as you are accustomed to if you've been to our workshops before. So get hyped. I do apologize if some of the information we covered today seems like a lot. I think it always does when you first come across this stuff, but it's really good to have at least some knowledge of what's going on before you encounter it a second time, like in your classes or in projects.
I think we can start now. Also, by the way, make sure you fill out the attendance or the check-in before you take this complete. All right, so I'm going to start. First question. Is it true or false the shell is a GUI or graphical user interface? It is false. It's a command line interface. And going on to the next one. Preston is at the top, followed by David and Dominic. So what is the name of the root directory? It's literally the name root, home, base, or /. Awesome, good, all got it. Okay, EMACS moved up to second place, and Keshav. So to move to the parent directory, use cd and then the period. Keyword parent directory. So if you want to go to the parent directory, you would use double periods or double dots. All right, so EMACS master race at the top. What's the correct way to append text to a file? Cat, stuff, typefile.txt. Okay, you guys all got it quickly. Yeah, so you would use the double greater than symbol to append to a text. Okay, job moving into first place. So the following reg expression will match to which string?
I put one tricky bit in here, so I'll be interested to see how we do.
So the last one.
All right, so I did put the little caret in there on one of them to mean not a lowercase letter. So just might be what confused some people.
Really tricky. Let's see how many people it got. All right, so David, or Preston and David, and then Michelle. So what is this regex? Where it means any non-alphabetic character, true or false. Notice
this is a bit of a trick question too, so be very careful before you answer. All right, so when it's inside the brackets, that caret means not this character, but when it's outside of the brackets, it means the beginning of the line. So a little bit tricky there.
So Preston at the top, then Dominic and Eric. So if your permission to execute a file is denied, what command do you want to use? Yes, perfect. chmod, which just means change mode of a file. The leaderboard stays the same. And so the attendance form had a weird question on which subject. Latino, anime.
Hey, everybody filled it out. Very nice.
Wow.
That makes me happy.
Yay. All right, true or false? Scripts can use loops, logic, and variables. Which is the correct keyword for statements between your if and else statements in shell scripts? Else, elif, or else if? A little bit weird, but that's how it is. Let's see. In third place, Eric, congratulations. Then at second, Dominic. And then in first place, we got Yeah. Preston, you get 2 gift cards because you answered the question and won this Kahoot.
Good stuff, Preston.
Thanks.
All right.
Great workshop.
Thanks. All right, we got one more bit to our workshop. I'll mostly walk you guys through this, but I will want a little bit of participation. So let's see how this goes. Let me share my screen again real quick if I can find that option. All right, cool. I'm going to go to terminal again. All right, so we're going to make a shell script right here. Let's see. I'm going to close this window real quick. All right, there we go. Okay, so everybody, I would recommend you open up a terminal if you don't have one now, and hopefully have a text editor ready as well. So you'll remember that we talked about some stuff that we wanted a shell script to have before, some requirements that we wanted. We wanted a script that would take in a single argument as a file name, look for the file in your current directory, and if you have that file there, you want to append some text to it. So hopefully that all makes sense. It should be in the slides too if you ever want to look back at all of those. So I'm going to create a file that's going to do that, and I'm going to ask for your guys' help in creating it. So I encourage you to do it along with me as well. So first, I'm going to create a new file. We can just call it script.sh. Now we're going to go into it with whatever editor you prefer. I would recommend EMACS, but anyone will work. All right, so what's the first thing that we always want to put in the beginning of our shell script? I have the chat open real quick. Shebang. Very nice, David. Yes, we want to put the shebang in there. So in case you guys didn't remember, that is our pound exclamation point followed by a bin bash, just to let the script know where we're going to execute all these commands. So as a side note, any other lines in your shell script that you start with pounds will be considered as comments. So if I say we want to, let's say I want to execute this script on sample.txt, just to remind myself for later on as test input. So that's just a comment to myself that sample.txt is what I'm going to use as test input later on, because it's just a file that contains text and it's something that I don't want to worry about messing up. All right, so what command do we know that we might want to use if we want to look for a particular file by name in our lower down directory? Is there any command we want that you guys remember? Touch script on H, not recognized. Keshav, are you on Windows or Mac?
I'm on Windows.
Windows, okay, that might be the issue. Can you sign into your CSNet account? If you're an engineering CS or EE student, you probably have an account. So that's just a real quick thing you can do to make sure we're all on the same page. Like the Mac terminal like I'm using right now is pretty much identical to like the Linux environment, but Windows is based on a different kernel, if I'm correct. So they're just a little bit wonky. Some of the commands work the same, some of them don't. So if you're having any issues with these commands, then just log into your CSNet and then you'll have access to everything that we're dealing with, in addition to EMACS, which is a bonus. All right, so just that question we were on, if we want to find a particular file in a lower down directory, what command do you think we want to use? Just type it in the chat or yell it at me, either way is fine. Hey, cool, good idea, Preston. If we want to find, I think we want to use find. So does anybody remember what our next option is in the find command? What our first thing we want to put in? What directory do we want to search? So we want to search the directory that we are currently in, right? And so that is represented by our dot. Great, exactly, good job, Raj. Okay, so if we want to search for a file by name, we remember that we had that name flag right here that we need to use for that. And for instance, and then what do we want to use? For now, I said that I wanted to use sample.txt, but we remember that for what we want the script to do, we want to take in an input as an argument, and that's what we want to use here. So does anybody remember the syntax for the variable that we're given that means the first argument? It's just 2 characters.
Is it $1?
Exactly, yes. So just put $1 right here, then it's recognized as a variable. So this means that we're going to find the name that we're looking for here. All right, so what we might want to do right here is we want to find the word count, for instance, of what this command returns, right? Because if it returns 0, if there aren't any lines returned by this function, then that means that we haven't found our correct file input. But if it returns a single line, then we'll know that it returned correctly, and we'll know that it found our sample.txt somewhere. So what we can do is I'm actually going to get rid of this real quick. What we can do is we can pipe the output of this into what command? If we're looking for the count of how many lines are outputted by our find command. Yes, great job, Preston. And I very much like that you remembered the L as well, because that means that we are only looking for the number of lines that are returned. Because remember, word count returns the 3 columns. It returns the lines, the words, and characters. All right, great. So we have a quantity right here that will hopefully be 1 if we get if we get a correct file name inputted. So what I'm going to do here is make use of the nature of the shell script, which means that we can use variables. So I'm just going to turn the result of that expression into a variable, which I'm going to very simply call var. Does that make sense what I'm doing right here? So this means that that quantity, whatever it is, will just be easily accessible later on in our script by calling that var variable. So hopefully that is all clear right now. All right, so now that we've found whether or not we have this file that we're inputting somewhere downstream in our file system, we want to do one thing or another. If we have found the file, what we want to do is take input in and append it to that file. If, on the other hand, we have not found that file, then we just want to end our shell script, maybe with an error message. So these are 2 cases right here. It sounds like a really great time for an if statement. So I'm going to give an if, and then I'll put my else down here. Now, does anybody remember what we need the line after an if statement in shell script? There's a keyword. Yes, Raj, that was a good idea. After our while loops, we need to do, and our for loops we need to do. But for if statements, we need then. So we're going to put then next under here. And then does anybody remember what we need at the end of our whole if else logic? Exactly, good job, Keshav. It's just the opposite of if, phi. All right, cool. So we've created this structure of our if else statement now, but we need a conditional. So does anybody remember what we put around our conditional statement? This is a little bit more challenging, but there's a certain yes, exactly, brackets. So in C and C++, we always put parentheses around it. But here we sort of want to know that we're executing some sort of statement. And so we do that with these 2 brackets right here. All right, so what is our if case? In what case do we want to append stuff to our file? What result will we get from var if we want this to happen? Var is greater than 0. Sure, that's perfectly okay way to do it. But I don't think I think it would be GE would be the flag then to test this. But just to make it super simple, I'm going to say if it's equal to 1, because it should technically only be 1 file of that particular name that we can find. So let's say, and if there are 2 files, actually we don't want to execute it, because in that case we might be trying to write to 2 different files, which would be super weird. So I'm just going to say if, and we're calling our variable, so we need to use that $sign notation. If this is equal to 1. So in shell scripts like this, we can't just use an equal sign or double equal sign in there. There's our specific flags that we use. One of the flags is -le, which means less than. I think one of them is -ge, which means greater than. So we use those instead of the usual greater than operator or equals operators. All right, And then one other weird thing about shell scripts is that after a conditional, we want to put a semicolon. That's just matters of syntax that you can look up later. So that's not super important to memorize. All right, so let's go to the else case first, because that's just easiest to write out. I'm going to just output some sort of error message. No such file exists. If, of course, no such file is going to exist. So we've handled our else case already. In any case where we don't get a single result returned in our search, then we want to say no such file exists. Although theoretically 2 such files could exist downstream, in which case we might want some other sort of case. But for now, we're just keeping it simple with 2 cases. All right, so the first thing that I think we might want to do if we have found our file is first give a message that says as much. So we can say file exists, enter text to append. And so there's one thing that I mentioned really briefly. I don't think I went over any syntax, but do you remember the command that I mentioned we could use to get real-time input from the user? This was very briefly mentioned. So I don't blame you at all if nobody gets this. Yes, exactly, David. We have a read command, and I didn't talk a lot about the syntax of this earlier, but what read can do is you just pass it a new variable that you haven't created before, and it'll read in input from the user into that variable. And so it'll basically turn that variable into a string. So what I can do is just say read, and give this variable a name, for instance, just simply n. And so all this command does is it will take in input from the user, and then it will assign that input to our n variable. And so what we want to do now is append what we've taken in to the file name that we've gotten before. So what command can we use to append our variable to the end of that particular file? Just feel free to type it in the chat. Cat we could use, but that's more for, yeah. See, cat does work for appending, but we more do that when we're outputting a file's contents to another file. If we're just simply doing a variable, or if we're doing simple strings, then we use echo to do that. So let's echo. But what do we want to echo into it? We want to echo our n variable, but what do we have to put before the n? If we're going to call it, we have to put our $sign, of course. Yes, exactly. All right, so we're echoing n, and then what is the name of the file that we're echoing our n into? $1, exactly. So this is just a really cool way of using our variables, because we don't need any static file names at all in here. So it's very flexible, which is cool. So at this point, I think our file is now complete. I think our script has everything in it that we need. And it should accomplish the task that we need it to. So I'm going to Command X, Command C. I'm going to save my file right here. Let's see, I'm going to run it, script.sh. Can anybody predict what's going to happen if I do this right now? Yes. Permission denied. Yes, I'm very much assuming, hey, look, it looks like our permission was denied. So what do I need to do? Can somebody give me the full command? Very nice. Yes, we need our chmod command. We need to add execution permissions to ourselves and give the name of the file script.sh. All right, so before I actually get into executing it, I'm just going to check what I have in sample.txt before, so we can be sure if our script actually works. So it looks like our script ends, our sample.txt document, I should say, ends with the word malarkey. So theoretically, after we execute our script, that should not be the case anymore. All right, so I'm going to execute our script.sh, and as an argument, it's going to take sample.txt. Whoops, looks like we have a little bit of a syntax error there. Let me take a look back. EMACS script, and I can guarantee that this will happen many, many times whenever you are creating shell scripts as well. All right, okay, here's the deal. So there's one really weird syntactical thing that we need to do up when we're first assigning our variable, and that actually involves a $ before this statement that we're executing. And now I think the reason for that is that we're sort of showing that we're shoving all of that, all the output from that into a certain variable. So it's just one weird syntactical thing that might be difficult to look at. But so make sure you add that in there. All right, so we have that now. So theoretically, this should work now. If it doesn't, then we'll have to make some additional. Oh, cool. All right, it looks like it worked. Similar.txt, no such file exists. 1 second. Okay, we've got one little issue right here. Line 7. Let's take a look at that again. Okay, let's see. One. Two primary and one second, let me find this issue. I don't think this is it. Let me just adjust this. I do apologize if this takes a second. Let's see if it was a spacing problem. All right, cool. So spacing, as I mentioned before, is very twitchy. Let me just kill this process real quick. Okay, let me get back to it. So spacing is a very twitchy thing. So if we're executing a conditional like this, we need a space on either side, which I forgot the first time, just because otherwise brackets start to interfere with like our patterns. So it might have been thinking that I was asking for this variable being equal to 1 bracket, which of course it's not. So make sure you have a space on each side of that. So that's just one of those little twitchy things about shell scripting. So let's run it again and see if this works. And hopefully it'll work on your end too. So we know the file exists. It has echoed the proper message. And now say we want to echo fooey into it. All right, cool. So that looks like our script is exited properly. So let's go back and we'll cat sample.txt and see if it worked. And would you look at that? We've got a line that says fooey appended to the end of our file. So is this working for everybody out there? Has everybody got a working script now? Great. If you're running into any issues, then feel free to ask a question. So otherwise, I think that concludes our, one second, missing.
I think, okay, I have like one slide that I added just for like the next workshop. I think you have to open the Google Slides again.
All right, so I'll do it. 1 sec. Preston seems to be having find missing argument to name. Was that one of the ones I was getting before? Argument to name. Is your spacing correct around name? Let me go back to EMACS up here. EMACS so up name right here, we should have parentheses around the whole statement. We should have a $ before. We need a dot right here, hyphen name, and then our $1. Is that how yours is looking, or is there anything missing from that line? And yeah, as I was saying, even the tiniest little thing is wrong, then it'll cause you issues. All right, tell you what, we'll take a look at that in a second. But first, let's just have Jackie share the last slide. We'll help you debug that after the workshop is done. Preston.
Let me just go in. Okay. So our next workshop, it's going to be about serial communication, and you actually need to get or have these 2 parts. The first one is an IMU, and then I linked it in the slides. It should be around like $5, and an Arduino Nano, which is like, this is like kind of the knockoff Arduino Nano, but it still works and does its job, and it's about like $8. And if you have like any problems like ordering those on Amazon, like let me know so I can order it on like my account, and then like you can just like Venmo request, or I can just Venmo request you. And so we have a very special game that we can make with this iMu and the Arduino Nano. As you can see on the right, it's a little game where you can make an iMu tilt-based controller. And that is pretty much it. If you have, if anyone has any questions about workshops in general, like feel free to stay after. But I think that's pretty much all we have. Travis, do you have anything else?
That sounds good. Yeah, that concludes all the learning part of our workshops. Yeah, feel free to stay and talk with us if you'd like, and we'll also do any debugging for anybody who's having any issues. All right, thank you so much, Raj. We're happy to have you here. And yes, there was a whole lot of learning going on in this workshop, and it might not have been fun at times, but it's all very important stuff that you're going to see again and again. So it's good to have exposure to it. And next week, I can promise, will be both educative and probably more fun than this week was, or next workshop, I should say.
Yeah. Also, I drew you guys on the side. I'm still not finished, but I'll DM you your portrait. You guys want to see who I have so far? I got David, Kishab, Preston, and Dominic for now. And then I also have Sophia, but I'm still working on it.
Beautiful.
Oh, Raj just turned on his video. But yeah, you guys have any like questions? I hope you guys learn some stuff about shell scripting.
Yeah, real quick, Preston, do you want to share your screen so we can?
Yeah, sure.
Get that? Cool.
You gotta enable it.
Oh,
Screen share.
Permissions. Yes. Okay, that should be enabled now.
Still getting it.
You are.
Try one more time.
Oh yeah, Jack. No, wait. There we go. It should work now.
Okay, there.
Cool.
No.
It didn't work the first time.
Okay. Okay. Oh. Okay. You can see it.
You need a second argument.
What happened?
Let's see. Find.
You need a second argument after you try executing the script, because you remember you need to you're trying to match a file name.
Oh yeah, it's an execution problem. Did you put your? I guess if you didn't create a sample.txt or another sort of text file, then it's not going to work. So I guess you should kind of do that.
So I need.
That's my bad. Yeah, that was a
my...
step I already had done.
Okay.
You can just create any
like
random
touch.
.txt. Yeah.
Okay. And now if I run it.
Yeah, now if you run it, you just need to have your second arguments be that sample 1, 2, 3.
Oh, okay. So in here.
No, not in here actually. So it's like, remember when we were.
Oh, so like when I actually run it, I need to put something.
Yeah, it'll be on the same line as you're executing the code. It'll just be like one spot to the side. Yeah, space and then give the name.
So just space and then the name.
Yeah.
Okay.
txt.
Ah.
Yep. And then you can write to it like that.
Okay. And then cat. Wonderful. Okay,
Perfect.
Thank you so much. Awesome. Thanks for the workshop, guys. It was actually so weird because I was just doing like the last few days like research on Linux stuff because it's the first time that I edited text in Linux in CS32 that I'm in right now. So like the timing of this was perfect for me.
Awesome.
But, yeah, it can be a bit of a bear when you're first encountering it. So it's good to know this stuff.
Okay, see you guys. Thanks.
Right, see you, Preston. Anybody have any questions or just want to hang?
You guys are both of you guys interested in workshops? Oh yeah, we should stop the recording.
This is true.